I'm Pete.
I'm Stephanie, and this is a bonus episode of the Cool Part Show, our show all about interesting, innovative 3D printed parts.
We are at Norsk Titanium, Plattsburgh, New York, production facility, additive manufacturing, using a process they invented called rapid plasma deposition. They make components out of titanium 6-4, mostly for the aircraft industry. We just filmed an episode here, this very detailed episode about this General Atomics wing splice part made through this process. Check it out, link in the show description. But while we were here, we discovered another part that has nothing to do with the aircraft industry.
That's right. The part we're looking at in this bonus episode is not for aerospace. This is for the semiconductor industry. This part is called a carrier tray, and its role is to hold a silicone wafer inside of a machine that performs photolithography. This is the process that creates the pattern of circuits on chips. So the thing about this tray is that it has to be able to move very rapidly inside of that machine. It faces something like 15 Gs of acceleration and deceleration. So it needs to be very lightweight as well as stable and rigid so that that wafer stays perfectly flat.
So this is the preform, what the tray looks like immediately after 3D printing. We'll get to more of that. Here is what the final tray looks like after machining. This tray was developed by Hittech, a maker of high-end machinery, including equipment for semiconductor manufacturing. The tray needs to be solid titanium because of the stiffness required, because of that speed with which it moves through this machine. And previously, the starting point for this tray was a solid block of titanium.
Solid block of material, and they were machining away something like 90% of it in order to get the tray geometry that they needed. So to tell us more about this problem and how they solved it, here is Koen Mentink. He's the managing director of Hittech in the Netherlands.
Yeah, so basically when the customer came in 2008, we started off with a titanium block, which was like 700 millimeters, so 0.7 meters by half a meter by like 11 centimeters in height. And it was an original weight of 220 kilos of titanium, and not the lowest or the cheapest version. And we think that our main product is chips or burrs, and we make like a 1.5 meter by 1.5 meter burrs out of this block. So that's 90% of the original weight. Product the customer buys is only 10% of the original weight.
Their main product was burrs, he said, chips, the chips that are the byproduct of all of this machining. 90% of that original titanium block was lost to chips that were machined away. And that material wasn't the only waste. Koen hinted at some others. All that machining required a lot of coolant, oil-based coolant. And then in addition to all of the material waste, all of that machining used a lot of cutting tools as well. Cutting tools worn out through all of that cutting of metal. Here's Koen again.
Yeah, if you look in the sense of how many tools we use in the part, it's typically 30 to 50 mills we use just to do the rough milling. But a cutter is like 70 to 100 euros, and you have to imagine that you use that up in 1 hour. So it's very expensive to mill titanium. Our part is very thin. And when you take away a lot of material, typically the material bends. So we also have to put some steps in to correct this bending of the material due to the stresses which are already in the material.
So that original machining process generated a lot of waste, both in terms of the material that was being cut away and in terms of all of the cutting tools that they were running through. But now Hittech, instead of starting from a solid block of material, they start with a 3D printed preform like this made here at Norsk Titanium. So there is still machining that is involved to get these preforms to the finished product, but it is much less than previously. They're going through fewer cutting tools. And all of this gets at the reason that Hittech wanted to pursue additive manufacturing in the first place, which is sustainability.
So Hittech did not yet have the customer's buy-in to change the process, but they wanted to identify and develop and be able to propose the more sustainable process. They started exploring, tried a lot of different choices. So real quick, they evaluated, instead of titanium, what about carbon fiber, another very stiff material? The challenge there, lots of fasteners go into the final tray, attaching different components to it. So many fasteners that there needed to be essentially many different titanium inserts for threaded holes. It was just simpler to let the entire thing be titanium. Titanium casting was another option. That could have worked, but tooling is required there, and investment in tooling, and the number of carrier trays that had to be produced couldn't cover that tooling investment. There's additive manufacturing through laser powder bed fusion, established metal 3D printing process, but to make these parts through laser powder bed fusion, very expensive way to go, cost prohibitive. But then they found additive manufacturing through Norsk Titanium's process, which is a much more productive and cost-effective additive process for these parts, in no small part because the build platform that the 3D printing layers on top of, that gets incorporated into the final tray.
Currently, we are like 20 to 30% cheaper, but we are at the beginning of a learning curve. If you look at the base plate, which is at my background, currently we have it, I think, triple as thick as we would use in the end product. And also with the walls, we use a lot of meat. It's also a bit, we have to explain to Norsk, in the aircraft business, it's very hard to change something once you started with the process. But in our business, our customer really likes that we have cost savings throughout the years. So they are open for changes if it doesn't mean a risk for them and if it saves them money or gives them some other benefits.
So the specific additive manufacturing method used here is called rapid plasma deposition. It was developed by Norsk Titanium. It uses 2 plasma torches to heat the material, and according to the company, it's capable of delivering forging quality parts.
What Norsk Titanium's really good at is what the aircraft industry calls buy to fly ratio. How much material do you have to buy versus how much of that actually flies in the finished component on the aircraft? Norsk can reduce buy to fly ratio by delivering the part as this near net shaped form that reduces the amount of machining required. The aircraft industry wants to reduce the amount of material that has to be wasted as chips. Hittech's parts don't fly, but they have the same problem, and the same solution works here as well. This near net shaped part, this preform, reduces the amount of machining required, but there's still farther to go.
Our customer sells machines which are in the millions. So I think the most expensive machine is as expensive as a Boeing 737 or an Airbus. And they can be that expensive because they make that much output. But if they have a disruption in this output, let's say because our part would break, then they get of course claims from their customers. So basically, they are they are even more reluctant occasionally than the aircraft business. So we needed to prove a lot. Now we are in a situation where we don't have to do that anymore. But in the beginning, we have to measure a lot on the part, like ultrasonic testing, CT scans, and things like that. But currently, I think we have them at a level where they trust the material at least as good as the former process with the full block.
So Hittech saw that switching to 3D printing would allow them to deliver the part more easily. It would provide those cost savings to the customer, allow for design changes, but they still had to convince the customer. These trays go into very expensive machines that can cost as much as an airplane, and any downtime is a really big deal. So the customer had to be sure that the 3D printed carrier trays would perform as well as the conventional ones.
Thank you, Norsk Titanium, for allowing us to film here in this Plattsburgh, New York production facility. If you haven't seen it yet, check out our episode on how General Atomics is converting previously aluminum parts of their aircraft to titanium using the rapid plasma deposition process. We'll put a link to that episode in the show description.
And as a reminder, if you want more cool parts, including early access to episodes like this one, sign up for our all access newsletter. You'll find information at thecoolpartshow.com. Thanks for watching.
Oh, shoot. Oh, that was good and I blew it. That was, okay, it's all my fault. I'm just gonna smile. I'm looking pretty.
Smile and nod, that's your job now.